Hello Year 10, hope you're keeping well. Today we're going to continue with another compound measure, which is called pressure. Pressure has to do with force and with area. So our question that we're going to start by thinking about is, which would you rather? Would you rather a woman who's wearing stiletto heels, so nice pointy heels, walk on your foot, or an elephant stand on your foot? Which one of those two things would you rather? Why do you think that is an important thing to think about? So she's got a really pointy heel and it's really tiny and it's going to go on one particular spot on your foot, or you've got a giant, massive elephant foot, which is really large and probably quite heavy, but spread over your whole foot. Things to think about. So pressure is a measure of how much force is applied over a unit of area. Pressure gets bigger if force gets bigger. Pressure gets bigger if force is more concentrated, and pressure gets smaller if force is more spread out. There's a nice little formula that we're going to be using, and that is pressure is equal to force divided by area. You can go ahead and write that down, or you can wait about 5 more seconds and we'll look at a nice little triangle. All right, so those are the 3 things that we're going to be thinking about today, and let's look at this. All right, so similar to our speed, distance, time triangle and our density, mass, and volume triangle, we have a pressure, force, and area triangle. So we've got pressure is equal to force divided by area, and if we can put the P, F, and A into the triangle, then we'll be absolutely fine to find the 3 different things. So by covering up the letter F, we can see that force is pressure times area. By covering up the letter P, we can see that pressure is force divided by area, and by covering up the letter A, we can see that area is given by force divided by pressure. When we look at area is going to be calculated in meters squared. That's a pretty general one, sometimes centimeters squared as well. Force is going to be measured in newtons, which might be something you've heard about in science. And pressure is going to be measured in newtons per meters squared. All right, I wouldn't panic too much about all of those things. They will start to make more sense when we look at them. So let's go ahead and try an example. All right, find the pressure exerted by a force of 8,000 newtons on an area of 25 meters squared. Give your answer in newtons per meter squared. So they want us to find the pressure. So we're looking for pressure. So if we cover up the letter P, we know that P is equal to F divided by A. So that is going to be the force, which is 8,000, divided by the area, which is 25. So we've got 8,000 divided by 25, which gives us 320 newtons per meter squared. And that's all we're looking to do. All right, it's a compound measure because we've got 2 measurements happening here, newtons and meters squared. And that's pretty much it. Let's try another one. All right, example 2. A crate exerts a force of 120 newtons, so that's the force, on a table. The pressure on the table is 15 newtons per meter squared. So this is the pressure. Calculate the area. They want us to find the area of the crate that is in contact with the table. Include suitable units. All right, if we're looking for area, I reckon we're looking for centimeters squared or meters squared. So we're trying to find the area. The area is given by the force divided by the pressure, which is 120 divided by 15. So 120 divided by 15, that is going to give us 8 meters squared. And the reason why it's meter squared and not centimeter squared is because in the question, they gave us the units in meters squared. All right, let's go ahead and try another one. Example 3. A box is placed on the floor. The area of the box in contact with the floor is 2.4 meters squared. So the area is 2.4 meters squared. The pressure exerted on the floor is 16 newtons per meter squared. So the pressure is 16 newtons per meter squared. Work out the force. So the force is we're going to find this in newtons. Work out the force exerted by the box on the floor. So we're looking for the force, so we're going to multiply the pressure and the area. So force is equal to pressure times by area, which is 16 times 2.4. Grab our calculator. 16 times 2.4 gives us 38.4. And we're looking for the force, so we're looking for newtons. All right, example 4. Find the pressure exerted by a force of 240 newtons on an area of 30 centimeters squared. Give your answer in newtons per meter squared. Oh dear. All right, so we've got centimeters squared here, and we've got meters squared over here. I think the first thing we should do is actually convert the 30 centimeters squared into meters squared. I think that's definitely going to be the easiest thing. Now, I've told you before, I never remember these things, so I'm going to draw this out how I actually would. So let's pretend this is a really bad looking rectangle, and I know that this side here is 1 meter, and this side here is also 1 meter. So the area would be 1 meter squared. But last time I checked, 1 meter is exactly the same as 100 centimeters. So I could say this is 100 centimeters and this is 100 centimeters. So the area would also be 10,000 centimeters squared. So I can now see that these two areas are equal to each other. 1 meter squared is the same as 10,000 centimeters squared. So if I want to turn 30 centimeters squared into meters squared, I'm going to go ahead and divide by 1,000. And that's going to give me 0.003 meters squared. From there, I can go ahead and work out everything that I'm looking for. So I know here's my force. I know here's my area. And I can go ahead and find the pressure. So pressure is equal to force divided by area, which is going to be 240 divided by 0.003. Grab my calculator. 240 divided by 0.003 gives me 80,000. And we're looking for the pressure. The pressure is in newtons per meter squared. All right, so most complicated part of this question is the very first step, the bit that's in the blue and the red ink. The green part is the fairly easy part after that. All right, moving on to example 5. The cuboid, the pink shape, and the cube, the yellow shape, are both placed on the floor. The cuboid has a weight of 60 newtons. The cube has a weight of 40 newtons. So the weight in this particular part is the newtons. So that is the force. The force is being exerted onto the floor. Which exerts a greater pressure on the ground? You must show your working. All right, so we're looking for an area, but when I see shapes like this, when I see 3D shapes, I'm typically thinking of volume. If we can try to draw underneath here. So this is an area that's actually back here. Can you see this rectangle down here? So that is the area that's on the floor there. So it's a really bad drawing, but go with it. So we're looking for that area down there. And in this cube, we'd be looking for this square down here. So in both of these, we're going to have to start by finding the area. The area in the cuboid is going to be 8 times by 3, which is 24. This is in centimeters cubed or squared, sorry. And in the cube, the area is going to be 4 times 4, which is 16. So now that we've got both the areas and we have both of the forces, we can go ahead and find the pressure. So the pressure for the cuboid is going to be the force divided by the area, which is 60 divided by 24. 60 divided by 24 on my calculator gives me 2.5. And for the, we should put some units in there. Pressure is newtons per centimeter squared this time because we're looking at centimeters. In the cube, the pressure over here is still going to be force divided by area. So we're looking for 40 divided by 16. 40 divided by 16 gives me, oh my goodness, 2.5 as well. 2.5 newtons per centimeter squared. So So the question is, which exerts a greater pressure on the ground? You must show you're working, and I'm going to say they're the same. The same! Can you believe that after all that working out? Chaos. All right, last example from me. A cylinder is placed on the ground. Let's draw a cylinder. So we've got a circle bit, and then we've got the two sides, and then we've got the other bit down here. All right, so there's my really badly drawn cylinder, but cylinder nonetheless. The cylinder has a weight of 85 newtons, so that is going to be the force, and it has a radius of 2 centimeters. All right, radius goes halfway across, so that bit right there is 2 centimeters. Work out the pressure, so they want us to find the pressure, that's pretty standard, on the ground in newtons per centimeter squared. Okay, so this is good because we've got centimeters squared here and we've got centimeters over here, so that is looking promising. Area, we're definitely going to need an area. Oh goodness, what area are we going to need? Well, hopefully you were listening when I was being dramatic and drawing my cylinder. The cylinder starts with a circle, and this circle has a radius of 2. So hopefully you remember that area is pi times by r squared. So that's pi times by 2 squared, which is 4 pi. Now I'm going to leave it as 4 pi in my calculator, and then it will give me a decimal at the end of everything. So they want me to find the pressure. Pressure is equal to force over area. So the force is 85 newtons. The area is 4 pi centimeters squared. Grab my calculator. 85 divided by 4 pi gives me a lovely answer of 6.76. And then this is in newtons per centimeter squared. All right, so that is probably as complicated as it's going to get today. You'll either have to convert your units to make it difficult, or you'll have to think about the actual shapes and find some areas. But most of today's lesson is just you trying to find pressure, force, and area when you're given only 2 of the 3 things. All right, let me know if you have any problems. And I would just like to point out that I'm very sorry. I just got a new pen to write with, and I didn't realize it was making such a loud tapping noise. So I'm really, really sorry about that. I'll try to fix that for tomorrow. Bye.